Okay, 5.2, which is binomial expansion. Now, this topic is easy, but at first it's hard and confusing, and unless you do things exactly as I do them, you're likely to get it wrong. So please be really, really careful with your notes for this one. Keep pausing the video, making sure you're copying the right thing down. And if you don't understand it, pause it and go back to it. It's a simple topic, brand new to all of you, so go slow with it. So what does binomial mean? So binomial, two terms, a polynomial, multi-term, binomial, two-term. So we're going to be expanding things with two terms to a power. Right, and the first thing we need to do for this, I'll give you guys a quick example. So try and expand these as I do them and see if you can keep up with me. So we're going to go for a plus b to the power 0, a plus b to the power 1, a plus b squared, a plus b cubed, a plus b to the 4, a plus b to the 5. And I want to have a quick race with you guys and see if you can expand these as fast as I can expand them. Okay, ready? Go. So that's the power of the binomial expansion. So it lets you expand things very, very quickly without actually having to write out the brackets and multiply them out. So some of you might have picked up when we're doing quadratic expansion that you get this thing squared plus two lots of this thing plus b squared. And it's a similar case for all these. You might be able to spot a pattern going on here. And the pattern that you can spot is Pascal's Triangle, which some of you might have picked up on during GCSE. So Pascal's Triangle looks like this. So you start with 1, then you get 1, 1, then you add this together to get 2. All the way down the side is 1. 1 plus 2 is 3, 1 plus 2 is 3, 3 plus 3 is 6, 3 plus 1 is 4, 4 plus 6 is 10, 1 plus 4 is 5, and so on and so forth. So those numbers are actually the coefficients. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Same numbers as in Pascal's Triangle. So, with binomial expansion, I'm going to go into detail of how we actually do it, but that's just showing you the power of it. And we're going to have something along the way to do with Pascal's Triangle. So, we'll go through some examples of how this thing works. So, we're going to try and expand that bracket using Pascal's Triangle. Now, I know it's just a cubed bracket, so you could expand that by multiplying, but we're going to try and do it the clever way using this triangle. So because it's to the power 3, we can look through Pascal's Triangle. Because it's to the power 3, I know it's going to be that set of coefficients. And when you expand something to the power 3, you're going to end up normally with 4 separate terms. So our first coefficient is going to be 1, then 3, then 3, then 1. And now let's imagine we had 3 in the same bracket next to each other. The first term would be x times the x times the x. We're going to get x cubed. And the pattern as this kind of goes is now we've done one of the brackets of the x. So we're going to have 2 x's times what's in the other bracket. So we're going to get this bit to 1 less power than we had it before. So we're going to get x squared, and we're going to get the introduction of the other term, so times 2y. Next one, we're going to get even 1 less of those brackets to be timing up, so we're going to get x, and then we're going to get the 2y term but squared, because it's being times out by its bracket. Then the last one, we've got no more x terms, it's just going to be if you like, that 3 times, so times by 2y to the power 3. And if we expand each one of those rows and add them all together, we've now expanded that reasonably quickly. So x cubed plus 3 times 2 is going to be 6 x squared y plus 2 squared is 4 times 3 is 12 xy squared plus 2 cubed is 8 8y cubed. So that is how we expand using the binomial expansion using Pascal's triangle. Basically, that gives us the coefficients, which is the numbers in front. And these terms, we have this to the power 3, none of those. This to the power 2, one of those. This to the power 1, 2 of those. This to the power, not there, and 3 of those. So each time the numbers of the powers add up to 3. So 3 and none, 2 and 1, 1 and 2, none and 3. Alright, let's try another one of these then. So we're going to expand 2x minus 1 to the power 4, which would normally take quite a while and would be very easy to make a mistake in it. So we'll draw Pascal's triangle out again. So because of power 4, I know it's going to be the row that has a 4 in it at the start. So again, those are going to be my coefficients. 1, 4, 6, 4, 1. And we're going to get this to the power 4, that's to the power 3, that's to the power 2, that's to the power 1, none of them. So 2x all to the power 4, 2x all to the power 3, 2x squared, 2x, none of them. And then we're going to times that by minus 1. So minus 1, none of them to start with. One of them next is times minus 1. Now times minus 1 squared. Minus 1 cubed, and minus 1 to the power 4. So again, we can now write the expansion. So 2 to the power 4 I know is 16, so 16 times 1 is 16x to the 4. Plus, we're going to get 2 cubed, which is 8, times by 4 is going to give us 32, times by minus 1, so we're going to get minus 32 x cubed. Okay, I'm going to run out of room here. Next, we're going to get 2 squared, which is 4, times 6 is 24, times minus 1 times minus 1 plus 24 x squared. Then we're going to get 4 times 2, which is 8, times minus 1 cubed, so it's going to be minus overall, so minus 8x. And lastly, minus 1 to the power 4 times 1. So there's our expansion of that bracket, again using the binomial expansion. Okay, now it's not the fastest having to use this triangle every time. And all this triangle is the number of ways you can arrange each of these terms based on statistics. So if we had this bracket written out 4 times, all that the 4, 1, 4, 6, 4, 1 are is how many ways of rearranging those 2 terms there are. So we can see there's only one way of getting to 2x times itself, always going to be the same. However, we can see if we're going to get the 2x cubed times the minus 1, well there's that one, there's that one, there's that one, there's that one. It turns out that there's 4 different ways of doing that in total, different ways of rearranging it. 6 different ways of timesing the 2x squared by the minus 1, 4 and 1. So these are all just the number of ways of combining 2 terms from a binomial when you expand them. So we can use a method from statistics to generate the numbers in Pascal's triangle. Our calculator will actually do that for us, and then we don't need to worry about remembering Pascal's triangle each time. So I'm going to write some notes about this, just so you understand where these numbers are being generated. And we call this the NCR method. NCR. I'll explain what all that means. So we're going to have to introduce you to this new thing called a factorial. And factorial is written as an exclamation mark. So 3 factorial basically means 3 times every integer lower than n. So 3 times 2 times 1. So 3 factorial is actually equal to 3 times 2, 6 times 1, 6. 3 factorial is 6. Factorials let us calculate the binomial coefficient much faster, and the binomial coefficient is the number from Pascal's triangle. And this all comes from statistics. So we end up with NCR. So we have this NCR thing. This is just a notation. It means n combination R. What it actually means is it's the number of ways, how many different ways there are of choosing R items from a group of n items. In other words, how many different ways there are of rearranging the terms in our binomial expansion. So as we saw just now, 1, 4, 6, 4, 1. That's how many ways there are of rearranging and getting the squared term, the cubed term, the x term. So basically it tells me how many x squared terms we would get when expanding x plus y to the power 5. So it's a much quicker way than expanding brackets and counting them all up, or than looking at Pascal's triangle. We can just use this NCR thing, it'll tell you how many terms you need. So what we end up with for NCR is this formula. So sometimes you see it written like this, and R is just a different notation. But what it actually is n factorial times by R factorial times by n minus R factorial. That's given to you in the formula book. So we'll go through very quickly an example. So if I want to expand this using this NCR method, my first term is going to be 4n C0, no x's at the moment, times by 3 to the power 4, plus the next term, 4c1, 3 to the power 3, power goes down, times by minus 2x, power 1, plus 4c2, times 3 squared, times minus 2x squared. So again, remember the powers will add up to 4 each time, plus 4c3, 3 to the power 1, minus 2x cubed, and the last term plus 4c4 times minus 2x to the power 4. 4c0 we can either work out by hand, so remember it's n factorial over r factorial n minus r factorial, so if we do some ahead, 4 factorial, 4 times 3 times 2 times 1, divided by r factorial, or in the first case r is 0, that's going to be 0, and 4 factorial will do the same thing, so we'll end up with just 1 there. If we do this one, for example, we've got 1 factorial times by 3 factorial, which will give me 4 overall. I'm going to get 3 factorial, which is this, cancel that, leaves us with 4 over 1 factorial, which is 4. So we can use that to generate our binomial expansion numbers. So here we get 1 times 3 to the 4, plus 4 times 3 cubed, times minus 2x, plus 6, which is the middle number of Pascal's triangle, times 3 squared, times minus 2x squared, plus again 4c3 is again 4 times 3 minus 2x cubed, plus 4c4, 1 times minus 2x. And if we work our way through that very quickly, we can simplify this. And we will get, so we can work this out and we can get 81 plus, using a calculator for this, 3 cubed times 4 times minus 2, which is minus 216x. Plus 216 x squared minus 96 x cubed, then plus 74. So we can use NCR to generate beginning number from Pascal's triangle, and we can do that on the calculators as well. So if you'll have a look at the class whiz, there is an NCR button here. No, I'll fix that later. There's an NCR button there, and you can type in, so 4C2, and you get 6, which is our middle number of Pascal triangle and the binomial expansion. Right, the good thing about this method is you can use it to find a particular term of an expansion. So we're trying to find the x to the 4 term. You actually want the coefficient, the number in front of the x to the 4 term. And I can't be bothered to expand this all the way up to power 10. We'd end up with 11 terms of expansion and loads of simplification. So we're going to try and use the NCR method to skip straight to that term. So the number at the front, we've got 10 in total. We want to find out how many ways there are of getting the x to the 4 term. So it's going to be 10C4. Next we need to work up 2 to the power something. So we want 2 to the power something, not 0, 2 to the power something. And then we want 3x to the power something. So because we want the x to the 4 term, I know this power has to be 4. We know the powers have to add up to 10, so this power needs to be 6. And straight away, if I work this out, I found the x to the power 4 term. So put all this into the calculator. So 10C4 gives us 210. 2 to the power 6, 64, and 3x to the power 4. Timesing it all out. So very quickly I've worked out the coefficient of x to the power 4 in this expansion in something that would probably have taken you half a day to expand, or at least probably a good hour, a couple of hours to expand that one. So you can use this very quickly to find coefficients. Let's try another example of that. So I find the x cubed coefficient in the expansion of 5 minus 2x to the power 6. So if you want to pause the video and try that, but I'll go through it now. So it's going to be 6C3 times by minus 2x to the power 3, because that's the one we want cubed. Powers have to add up to 6, which will also be times 5 to the power 3. Now we can work it out. So 20 minus 8 and 125, times all those together. Which gives us minus 20,000 x cubed. So the coefficient is minus 20,000. Right, I can make these questions a bit more difficult. So the coefficient of the x cubed term in the expansion of that is this, find k. So we're going to expand this, not knowing what k is, set the x cubed term equal to 14,336, then use that to find k. If you want to pause the video and try it, do it. This one is quite tricky. So the x cubed term is going to be 8c3 times, we want x cubed, so it's going to be kx to the power 3, and then 2 to the power 5. And that should be equal to 14336 x cubed. So on our calculators, 8c3 56, k cubed x cubed times 2 to the 5 times 32, times all that together. So 1792 k cubed x cubed equals 14336 x cubed. So that amount of k has to equal 14336. So divide it by 1792. So k cubed equals 8, therefore k is 2. Alright, last example. Okay, so find the first 3 terms in ascending powers of x of the expansion of this. So it looks quite difficult, but it's not that bad. What we're going to do is expand this up to the first three terms, and then multiply it all by 2 plus x. So, first three terms of this, so we're going to get 5c0, 1 to the power 5, plus 5c1, 1 to the 4, minus x to the 1. And then 5c2, 1 to the power 3, minus x squared. So that's our first three terms, 1, 2, 3. And they're going to be the terms that we're going to multiply by 2 plus. Okay, so now I'm going to work out each of these terms and then times it all by 2 plus x. 5c0 is just going to be 1. 1 times 1 to the 5 is going to be 1. 5c1 is going to be 5. 5 times 1 is 5 times minus x is minus 5x. And 5c2 is going to be 10. 10 times 1 cubed is 10 times minus x squared is 10x squared. So that is all 1 minus x and 5. We now need to times that by 2 plus x. So multiply this out. 2 times 1 is 2. 2 times minus 5 is minus 10x. 2 times 10x is plus 20x squared. Now times it all by x plus x minus 5x squared plus 10 x cubed, which you don't actually need because it's not part of the first three terms. Simplify this. 2 minus 9x plus 15x squared. So those are the first three terms in the expansion of this. So we managed to skip quite a lot of steps there. Cool, right, Bill, try the quiz. I'm going to do another video, just a lot more practice on this if you are finding it difficult.